My name is Kumar Venkateswar. I run the product management team for Amazon SageMaker. And I'm here to talk about DevOps of machine learning with Amazon SageMaker. I truly appreciate the amount of time that you guys are spending with me and the enthusiasm that you have for SageMaker. And hopefully this will be a useful bit of time that you spend with me. So overall, I want to talk about some of the DevOps challenges that people encounter in machine learning in general, not necessarily related to SageMaker or AWS, and part of the reasons for the genesis of those challenges. And then we can talk a little bit about SageMaker, what customers say about it. In AWS, we typically like to illustrate these things through customer examples, so I have an example that I'd like to talk about. And then I'll give a brief introduction as to what SageMaker is. And then I'll talk about how SageMaker can be used as part of a portfolio of services that you would use to address those DevOps challenges. And then I'd like to take some questions. I know we're running a little late overall. Between this talk and the talk on automatic model tuning that's coming up later, I'll try and get you guys out of here by 1 so we can have lunch on time. So let's go ahead and dive in and talk about some of the challenges that people encounter when they're trying to operationalize machine learning. Because really that's the thing that I'm focused on as the SageMaker product owner, and it's something that I think is very critical. In general, if we, how many of you have seen this slide before? Only a few of you. Okay, great. So in general, the machine learning process is pretty hard. There's a lot of stages that you go through. It's something that is very unique to machine learning and is not shared by the rest of software development, which means that it's even harder because there are no processes set up around it. First, and the reason for that is because it's primarily machine learning originated out of data science experimentation. So the way people think about this is as a science experiment. How do I experiment? How do I do this one-off? And then at the end of it, I get a model. What you do with that model, who knows? But there's a model. And that's the way people have traditionally thought about it. So you end up with a lot of these non-repeatable heavy lifting processes. First, initially you try and set up an environment where you can safely store your data and be able to analyze that data, process that data, and so on. And that generally ends up taking a bit of time as you try and secure the environment. Sometimes it's the data scientist's laptop. Ideally, it's something that's a little more secure than that and can't be lost at an airport and so on. But you set up this environment, you load in the tools, you get it set up exactly right so that you have the drivers all lined up, the software all lined up. I actually, in the past, I've set up an environment like this. It's taken me hours to make sure that all of the driver versions compiled into the software as well as installed on the box are the same. It ends up taking somewhere between hours and weeks to set up this environment. And then there's a challenge around labeling the data. So you have a bunch of data. It's usually dirty in some way or the other. It's non-uniform. You need people to pre-process it. You need to be able to add annotation to that so it has the labels that you need in order to answer the machine learning question. So then a couple of weeks have gone by. You finally got your environment. You're ready to process through it. And then you say, OK, I'm ready to start training. And initially, if you've got small data, you take a sample of the data and you train. And you're like, OK, I've got this trained model. I think it'll work well on a bigger set of data. And in order to work on that bigger set of data, I'm going to try and use a cluster for it. And that's hard. Setting up a distributed cluster to do machine learning training is hard, time-consuming. In fact, it's so hard that a lot of the customers that I've talked to end up leaving their clusters up and running, paying for it the entire time, 24/7. And then they have a priority queue that says certain jobs need to be prioritized over others and so on in order to make sure that they're utilizing that cluster correctly. it's a mess. Scaling up and making these algorithms work is really hard. And then once you have this model, you need to put it into an application because the model itself does no good to anybody unless it's incorporated into an application. So they take that model and hand it over to DevOps at that point. And you look at it and you're like, what do I do with this model? It's not going to meet any of my operational characteristics. So you end up with this cycle that takes anywhere between 6 and 18 months in order to get this model into production. And part of the challenge is that machine learning tools are different than the ones that are traditionally used by DevOps audiences. So you have a set of things like Anaconda and scikit-learn, and some of those are the easier tools to use. And then you have deep learning tools that are pretty sophisticated, hard to get right, have a lot of adjustments that you need to do. And I'm not even talking about things like MPI and Horovod, which are really, truly hard to get set up right. And then you have Spark, and there's even a set of things like Apache Airflow and MLflow where people are trying to develop these machine learning specific tools to help with the operationalization of machine learning. And part of that is because the ML challenges are different than the DevOps challenges. When you talk about DevOps, you have a whole set of things around, is this software compliant? Is it in the right regions? Can we audit it? Can we look at the security of it? Is it actually maintaining the security of the data? When it's a one-off experiment, you don't need to think about these things. When you're doing this day after day in a repeatable process, all of these things become important. Is it portable? Can I actually take that application and move it to different environments if I need it? Can I take the model from iOS to Android so that I can develop an Android app? Can I take it from on-premises to the cloud? Or, essentially you need to be able to move it around. And all of that needs to be done in an environment where it's always up and running. So it's one thing if you're doing this one-off, but if it's something that you're building a business on, it needs to be up and running all the time. And that's a different challenge altogether. And then if you're successful, you're lucky, then you need to scale it out so that it takes your peak loads. And all of these are different challenges than the machine learning challenges that we talked about. So what happens is DevOps gets involved too late. This is really the root of the problem. The scientists will work on these small data sets, and then they say, okay, I'm good. It might be pre-cleaned, so I'll have a data engineer clean up that data for me so that it works well for machine learning. It's not necessarily a production-ready process, so it may be done in a non-repeatable way. And you end up doing this in a very dedicated environment that is separate from the production environment. So these science project things get tossed over the wall, and DevOps doesn't know how to implement them in production. And then all of the DevOps challenges are something of an afterthought. And what ends up happening is that it doesn't end up being as useful in production as it was in the science experiment. So everyone ends up being disappointed with this entire process. It took too long. It ended up in production way too late, and the results were not great. So what is SageMaker? I usually talk about SageMaker in the context of the overall AWS ML stack because we're not trying to, SageMaker itself isn't the silver bullet solution for all of your ML problems. We believe that there is this entire spectrum of needs that you have, and we have different services to meet different needs within your organization. The AI services, the top layer of the stack here, those services are the easy to use. I have this problem that I know machine learning can help with. Amazon, help me with solving these problems. Pick out objects from images or recognize entities from blocks of unstructured text, that kind of thing, where these are common problems across a lot of industries, and Amazon has good expertise to bring in order to make that easy. So the AI services are actually the easiest to use out of the box. But then there's this set of problems that is unique to your business. What is the unique value that you can provide to your customers that you want to develop, that you believe is the core of your business? So in order to help with that, our goal is to make it so that you can bring your data in, that you can develop expertise in that area, and that you can operationalize it. And that's where SageMaker fits in. And this is built on a foundation of a lot of open source projects that we contribute to, that we participate in. This whole community is something that we are dedicated to making a difference in. And this foundation is what it's built on top of. This, along with things like Intel-based compute, NVIDIA-based GPUs, a strong storage infrastructure. That infrastructure layer is what enables us to provide services that enable you to move quickly. So the goal here is that this is your quickest path from idea to production. I've personally been involved in machine learning projects where it took me 6 months to go from the data science telling me, hey, this is working out really well against historical data. Let's push it into production. 6 months later, it gets into production. This is not the way to do machine learning. Machine learning builds on machine learning. You learn more as you go along. It's iterative. You need to be able to push things into production within days to weeks at worst, weeks at worst. So SageMaker is intended to help you push things into your production environment. And how does SageMaker do it? It basically helps you with all of the challenges that I outlined through the entire cycle, or it tries to help with a lot of these challenges. So you have these notebook environments that are customizable, that integrate together with your Git repository. So you're bringing the data scientist into the rest of the DevOps ecosystem in that way. It has built-in security features. It uses the AWS Virtual Private Cloud and Private Link. It encrypts the storage using a customer-provided key. So it maintains the security of the data. It's something that you can feel confident that if you use these environments, that your data is held securely. It provides you with automatic cluster setup and teardown. It provides you with algorithms that you can use to get started. It provides you with frameworks. There's an AWS marketplace for machine learning in which you can purchase the work of other people and use those algorithms as well. So the idea there is you would be able to get up and running as quickly as possible while you develop your own expertise in the area. It provides automatic model tuning, which is something that I'll talk about in our next time together after this talk is over. And it provides this in a way, like, because it provides cluster setup and teardown, it actually provides you with a lower cost solution than the solutions that people usually use, which is this persistent cluster that runs regardless of whether you're actually doing machine learning training or not. Instead of having that persistent cluster, you can spin up and spin down, and it provides you with a good way to reduce cost there as well. The next, if you look at how it gets deployed, again, it lets you set up these clusters on demand. You only pay for the instances that are up and running, which means that you are having reduced cost there as well. And it has integrated autoscaling, which means it can scale up to meet your peak demand and scale down as well. It's integrated with CloudWatch for monitoring. And it has features that allow you to optimize for hardware as well. So SageMaker Neo will compile a model for a specific hardware target. And we provide elastic inference, which will further reduce the cost on the inference side. And this is something that Intuit is one of the early customers that has realized a lot of benefit with SageMaker. First, they moved one model over, and then they said, wow, this is going really great. And in the next, I think the first model took them 6-ish months to move over, and then they moved another 5 over, and I think that took roughly 6 months to move over, and then they're moving another 25 over. So if you look at the way these things progress, they're able to move a lot quicker, and they're able to develop these models much, much faster than they were able to prior to SageMaker. What I heard from the Intel folks when I talked to them at reInvent is that they were able to bring their model development time from over 6 months down to less than 2 weeks, which is amazing if you think about it. This is the kind of thing that you need to be able to do if you're building a machine learning company. You need to be able to do these things in a repeatable fashion, and you need to do them fast. And if you look at Intuit, this is a company that deals with, I want to say something like 60% of the US's tax data. So they have a very, very high bar for security. They're very concerned about things like fraud, and they're able to put their critical machine learning problems on SageMaker, and they're able to run faster as a result. So part of what SageMaker provides is this notion of modularity and this notion of being able to choose exactly how you want to use SageMaker. And a lot of data scientists and machine learning scientists are very particular about the way they work, and they want to use their own tools. They want to use the environment that they're familiar with. And the reason for that is because they're solving really hard problems. So if you say, hey, you know what? I'm going to give you a tool set, and you have to use this tool set, and you have to solve these really difficult problems, it becomes a double challenge. So instead, what we decided was we'd build SageMaker in a way that it works with the data scientists. It works with the way you work. So if they want to use this, the hosted notebook instances on SageMaker, those are there. If they want to use their own laptop, that works too. You can still use it from your own laptop. You can use it from Spark. You can use it. I actually have one customer who's using their entire machine learning workflow is from the console, which is a little surprising to me, but you know, we provide this because we think they're useful even for small numbers of customers, and we're trying to make it so that you build it your own way. Similarly, for training, we want it to work the way that you want to work. With zero setup, we want it to be so that you can use the built-in algorithms, you can use the marketplace algorithms. If you feel like you have IP that you would want to share with other people and you'd want to be able to monetize it, you can even use the marketplace as a way that you can publish your own work and provide others with a way that they can easily use your IP in-house. We also work with all frameworks. So we have example containers that we've provided for TensorFlow, for MXNet, for PyTorch, for Chainer. It's not limited to those. All of those containers, we've even open sourced them. So if you want to take them and fork them and develop your own in-house Docker containers, you can do that. Or, I mean, essentially, you can use Docker for your own custom algorithms, and you can bring your own expertise and your own IP and still use SageMaker in all of the ways that I described. I'll just talk a little bit briefly about the built-in algorithms. The built-in algorithms are nice for traditional machine learning problems because they're built for really high scale and built for reliability. And it's the quickest way to get started with things like linear regression or gradient boosted trees or the like. And it really doesn't, it isn't necessary to have multiple implementations of linear regression or PCA or k-means. There really is a very few efficient implementations of that. So as a result, we've provided a set of, I think it's up to 18 now built-in algorithms that you can use for various problems. Everything from the general purpose to things like sequence-to-sequence, language-focused ones, object detection, semantic segmentation for images, and we even launched IP Insights, which helps you with login anomaly detection in the security space. So the idea there is we'll provide you with a good set of built-in algorithms, and the marketplace will provide you with additional algorithms that you can use, even if you don't have that expertise yet in-house. And then you can deploy your own way as well. You can deploy into into SageMaker, and I'll talk a little bit later about the deployment methods. But essentially, you can even bring your model in from outside of SageMaker. If you chose to train in the SageMaker notebook, or if you chose to train in Spark, I have customers that are training in their own on-premises Spark clusters, and they say, this deployment part of SageMaker is really useful for us, so we'll just use deployment. SageMaker is the set of loosely coupled services that you can use in order to help you speed up your machine learning workflow. We're not going to say you must use all of the SageMaker components in order to get use out of it. And similarly, you can also automatically tune models. The one thing that I want to call out here is that you can automatically tune models that you brought yourself. So even if you brought in a Docker container with your own secret sauce algorithm, you can still use it for hyperparameter tuning. So the goal here is that we want to make common development tools easier to use for ML. We want to make Docker easy. So for the most part, even though Docker is the underlying technology that we use for a lot of SageMaker, data scientists don't really need to know how to interact with Docker in order to use SageMaker for that purpose. Similarly, we announced Git integration, and I can demo that shortly. We announced Git integration that allows the data scientist to work with Git. And one of my customers said, we just had a data scientist consultant start with us, and she, for the life of her, won't use Git. She can't figure out how to use Git. She can't check in stuff. She really just doesn't want to use it. And for that reason, I mean, it goes back to what I was saying about data scientists like their tools. They want to use only their tools, and they are really focused on hard problems, which means that the tools need to work with them. And that's the philosophy that we used in order to develop these integrations. Similarly, with AWS step functions, when it comes time to operationalize these, we integrated together with step functions and Apache Airflow so that you can take the processes that scientists use and operationalize them very easily using SageMaker and the integrations with other services. And then it also integrates with Autoscale and monitoring and logging so that you can use that in the same way that you use other AWS services. So let me quickly kind of show you what it looks like and do a little demo of it. And then we can continue talking about how you can use SageMaker to address these challenges. So I've got the console loaded up. And one of the things that you notice as part of the instance settings is that you're able to specify a Git repository as part of the configuration. Likewise, you can supply security groups. You can enable or disable internet access. And all of the traffic from this to my VPC, because I've specified a subnet and I've specified a VPC at instance creation, all of this traffic will go through Amazon networks. None of the traffic goes through the public internet as long as I'm accessing private link endpoints, which is a really big plus for companies that are dealing with sensitive data, financial data, healthcare data, government data, that kind of thing. So if I actually, let me do it from here. So I'll open up the Jupyter Lab notebook view. And it goes straight into Jupyter Lab, which is, I guess I can't open up two of them. It goes straight into Jupyter Lab, which is a convenient environment that data scientists are very used to. This is the kind of thing that they work with on a regular basis. But at the same time, you have Git integration with it. And they don't need to think about it. It syncs the changes. It detects the changes. You can push those committed changes very easily. You can stage the changes for commit. So if I put in comments here, I can stage those changes and so on. So it provides a really convenient environment in which the data scientists can work and they can stay in this environment and they're not forced to switch between tools that they're familiar with and unfamiliar with in order to work with DevOps in your organization. So let's go back to this. So again, we look at these DevOps challenges. I briefly mentioned them. How does SageMaker work in order to address these challenges? To start with, for compliance and audit, AWS views this as a shared responsibility between you guys and us. So we will maintain the compliance of the cloud, and you maintain compliance in the cloud. And that's the way that we look at it. So as part of that, there are certain services that are in scope for several compliance regimes. For SageMaker in particular, we're in scope for ISO, we're in scope for PCI DSS, we're in scope for SOC 1, 2, and 3, and we are compatible with GDPR and HIPAA for those that deal with healthcare data, and ITAR as well, which is sort of a more US-specific thing. This is a list that continually grows. This is a list that we're trying to make sure that we have are compliant with various regimes. And part of this is because we know this is important for operationalization. Like, it's great if it's a science experiment, if it's a one-off. Usually you can get your internal people to sign off on something that's internal only in an experiment. But when it comes time to production, you actually have to make sure that you're adhering to the appropriate laws when it comes to dealing with data. We're, in a similar fashion, we're available in 14 different regions, including India, which is something that we launched in November. We're continuing to be aggressive about regional expansion. We know that's something that's important for people who deal with data that has to stay within the borders. The goal is that you would be able to use SageMaker for all of these types of problems. And we integrate automatically with AWS CloudTrail, which means that you have an audit log of all of these actions being recorded in a place that's convenient to work with for compliance purposes. Another thing that we've spent a great deal of effort on is security, because the data that people usually want to do machine learning with, I've had customers that come to me. Usually the first thing that they say is, we want to put business critical data and do machine learning with our business critical data. Frankly, that's not what I would recommend starting out with. I would recommend starting out with something that's a little easier and doesn't have as many challenges as your business critical data, but that's clearly where customers want to get. And because it's business critical data, it's the data that is most crucial to your business, we want to make sure that we're acting as good stewards and providing the appropriate level of security for that. So we do things like, SageMaker itself doesn't store data, except for intermediate data in ground truth and intermediate data within things like training and so on. We don't persist that data. The data gets persisted in your account, under your control, encrypted with your key. And this is important because we don't retain any control of the data. We don't retain any data. We actually provide all of that data back to you, put it in your account so you can control it, delete it, do whatever is needed in order to manage your own internal policies. So you manage the lifecycle of the data, all of the artifacts, everything that is associated with it. And because of that, we don't retain permission to the data either. So in order to have permission to access your data, in order to use your Docker containers and so on, you pass in a role. You pass in an IAM role to SageMaker, so SageMaker has that permission for as long as we hold on to the IAM role. And then once the operation is done, once training is done, or once we're done with autoscaling, we toss that role away so that we no longer have permissions to that data. We also don't use shared instances. So the instances that we use are dedicated to you, and that means that relative to some of the attacks that we've seen, Meltdown, Inspector, and so on earlier in the year, that's not something that's as much of a concern because those instances aren't being shared. We also, if you specify a key that you manage, we use that key for encryption at rest. We encrypt all of the artifacts, including the model artifacts. If you specify a key for that, we encrypt those. And you may ask, why the model artifacts? Because is that really important to encrypt? And what I would say to you is there are these attacks that are model inversion attacks that can potentially regenerate some of the data based on taking the model and having some of the data available. They're able to regenerate some of the other data. These are attacks that are pretty sophisticated and sort of niche attacks and researchy attacks at this point. But at the same time, when you start putting this production models into production and you put business critical data into production, we want to make sure that you have the tools that you need in order to secure all of the information, including the model artifacts. And then in transit, we use TLS between all of the components that we have. We also support virtual private clouds, which means that none of this data will go over the public internet. We encrypt it, but we also give you the ability to make sure that none of this data goes over the public internet. So it's encrypted even within the Amazon network. And we support private link so that when you access those Jupyter Notebook instances, you can access them through your VPC, so even that data doesn't go through the public internet and so on. So we treat this as something that is critical to provide you the tools with so that you can operationalize machine learning. It's not a one-off experiment. It's something that you need to be able to do repeatedly. It's something that you need to have templates for to create this environment. It's something that you need to customize for your environment and be able to, when a data scientist gets onboarded into your organization, be able to say, here's your notebook instance. You can get up and running quickly, and we know this is an environment that has the tools for you, is secure to use with the data that you need to access so that you can get up and running. We also give you the ability to configure the notebooks so that they don't have internet access and so on in order to make it a truly sequestered environment. So the next thing is I've heard from quite a few customers that they're looking for portability between environments. Some of the applications that they have are appropriate for SageMaker and some are not, and some need to run in on-premises for business reasons. These are things that we want to enable. And yes, we're very happy if we're able to serve you with SageMaker hosting and in the cloud, but at the same time, we know that there are business considerations that make it such that not every workload is able to run that way. So SageMaker is designed in a way that lends itself to portability. It uses Docker containers. Those Docker containers, the ones we produce, are open sourced. The libraries that we produce, whether it's the Python library that you can use on your desktop or in the notebook instances, the Python libraries are open source. The Spark library is open sourced. We really want to produce an environment that allows you to seamlessly move from environment to environment as your business dictates. We believe that a large part of it is best in the cloud, but at the same time, if you have business constraints that make it so that you can't use the cloud for everything, we still want to enable your business. So we've designed things to allow you to be able to take advantage of some of our work, even in other environments. And we also deploy with availability in mind. So AWS in general has multiple availability zones per region, and we automatically deploy into multiple availability zones in order to maintain high availability. And of course, just like everything else, we monitor the infrastructure in order to make sure that everything is up and running and works seamlessly. So the last challenge that I want to talk about is scalability. And this is one of those challenges that you only encounter once you're in a production environment, which is why it becomes much more of a challenge. That's the point at which if you go with the toss the model over the fence kind of approach, you end up with stuff like this, where, how do you operationalize it if you have this kind of spiky workload and it wasn't designed with that in mind? The way we do it is we provide integration with AWS application autoscaling, and you can basically set the min and max instances. You can set the number of target invocations so that you're able to say each instance we believe should be able to take this many invocations. I think we recommend that you scale up at 50% of the max invocation so that you have a little bit of buffer, and it'll scale up at the point at which you choose. So once you actually see this in action, you essentially see the load go up, and once autoscaling kicks in, when it's up above that threshold, you see the number of invocations per instance actually goes down because you transitioned over to the point where you have an additional instance. In this particular case, I think we transitioned from 1 to 2 instances, so it's pretty dramatic. In most cases, if you actually look at a production workload, it's not going to be that dramatic. It's going to drop a little, but because you're already running at scale and you're just adjusting the number of instances to suit the traffic, it won't be quite this dramatic. The reason we chose the scaling criteria as the typical scaling criteria as being invocations per second per instance is because there's a great deal of non-uniformity between the requirements of each of these algorithms. There's different memory requirements, different CPU, different GPU requirements, all of that kind of thing, which means that essentially the invocations seems to be the lowest common denominator scaling parameter that you can use. Of course, if you develop your own custom algorithms and you emit to CloudWatch, you can actually use those. There's no particular restriction on what scaling parameter you can use. We can consume anything based on the instance's CloudWatch metrics. But because we wanted to provide a pattern that could easily be used by you, we chose invocations per second. And if you look at the way that these are specified, it's actually specified in a pretty simple format. You just register the scalable target, and you provide the parameters for scaling min and max instances and that kind of thing. And then you provide the policy that you would use in order to make it scale on, in this case, number of invocations per second. So if you scale by utilization in this way, this is essentially the way that the scaling works out. So if you look at SageMaker itself, we also provide you with a number of options for deploying. I've talked a bit about some of the scalability characteristics are mostly centered around real-time deployment, but that's only one of the options that you can use for deployment, and it isn't necessarily the right one for all of the business use cases, which is why we provide you with multiple options for doing that. You have real-time deployment, but you also have batch transformation. We integrate together with Greengrass ML, which allows you to deploy to devices. You can even take the model artifacts out, and you can deploy them straight to devices using your own pipeline. I know there's customers, I have customers like GE Healthcare who deploy to X-ray machines. I mean, you can't really expect Greengrass to be running on their X-ray machine. So they have their own deployment pipeline that they use. They have their own processes around that, but they're still able to use SageMaker for training, and they're still able to operationally deploy it to all of their devices using that. And you can even deploy on whatever local environment you want, because all of those artifacts, all of the results of training are in your account. They're fully under your control. You can do whatever you like with them at that point. You're not locked into SageMaker. So the two options that are built into SageMaker are real-time and batch transformation. Batch transformation is something that we launched in July. Real-time, we had it at launch in November of 2017. There's two different use cases for that. You can get some of the goodness of both of those cases depending on what your business use case is. Some customers actually will do things like, if the data doesn't change over the course of a day, and they still want the low latency characteristics, they'll do things like batch transformation, load it into DynamoDB, and then use that DynamoDB's low latency access time in order to pull in the inferences. So you can do things like that in order to address some of the use cases. Both of these are similar in the way that they work. They use similar containers. And part of that is an advantage as well, because if you actually look at how data scientists work, data scientists typically end up working in a lot of batch environments. They don't have a lot of real time, because if you think about real time as a notion, that's something that's a production characteristic. So when they're working on historical data, they don't really have this notion of real time. It's a little strange to set up a real-time endpoint and then feed things to it in batch. So the advantage of using this type of environment and using an environment in which you have the same Docker container in both real-time and batch is that when the data scientist works on this in a batch environment, they're able to take that same container, and then as a DevOps engineer, you can deploy that same container into real-time, and then you don't have a discrepancy between the environment in which the data scientist was working and the environment in which you're going into production. Just briefly talking about the benefits of batch transform, it's pretty low cost and it's pay as you go, because SageMaker, just like for training, will set up and tear down the clusters. You don't have any persistent instances. And during the course of time when you're actually doing inferences, because of the embarrassingly parallel nature of inferences, you end up with very, very high utilization, which also contributes to lower cost for inferences. Of course, if you need real time and if you need that low latency response, you can also use SageMaker in these real-time environments. I'll kind of skip over this. This is the way that you would configure a real-time endpoint. Briefly talking about how you would update an endpoint, because again, this is a production environment. So when it's integrated together with your application, you don't necessarily want to have to do an application deployment every time you update your model, which means that you need to be able to update those. And we do blue-green deployments within SageMaker in order to update the model, which means that at all times there's a model up and running and serving your application. So you're able to swap it without any loss of availability. In addition, the same infrastructure can be used for doing things like A/B testing. If you actually want to try and do incremental training, or if you want to try new models and update the algorithms, you can actually deploy both of them behind the same endpoint. You can provide a weight, and you can see whether your KPIs have changed as the result of deployment. Just briefly to kind of talk about a few things that I didn't really touch on. There's a lot more. There's a lot more. SageMaker is really focused on making sure that you're able to operationalize machine learning. So I encourage you to go and look at the talks that were done at reInvent on ground truth. Ground truth is a way that you can operationalize human in the loop in order to label your data. We've also worked on reinforcement learning, which enables you to easily set up reinforcement learning environments the same way that you would set up more traditional supervised and unsupervised learning environments. You're able to compile models for specific hardware targets. You can even go back and trace from a deployed model back to the training data set using SageMaker Search. That's something that we launched in beta, should be going GA soon. And with step functions, we had a customer, Cox Automotive, basically show that you can use the SageMaker step functions integrations that were announced in order to put a human approval loop as part of your model deployment process. So they have this pipeline created in step functions that automatically trains the model with data on a regular basis, and then takes that data, takes that model, passes it to the data scientist for human approval, and once they approve, then the model gets deployed into production. So you can do a number of these things in order to make sure that you have the right processes in order to operationalize your machine learning. And with that, I'll take a few brief questions. I know we're quite a bit over time, but I'll try and take a few questions if that's okay with you. Thank you all for the time. Go ahead, please.
You said that SageMaker runs separately, that runs in the shared instance.
Yeah, so SageMaker does not use shared instances.
But then you said that it's running in the Docker container. Are you running Docker container in a single machine?
Yes. So
One Docker container, one machine?
it is not one Docker container. And so what I'll say is we use Docker not as a way to share the instance with other customers. It's your own instance. But the reason we use Docker is that it's a convenient way to deploy code onto an instance. You can deploy multiple Docker containers of your own container onto real-time scoring. So we have the notion of these pipelines. So you can deploy up to 5 instances in a pipeline into the real-time scoring environment. We also have another Docker container to help facilitate connections with monitoring, to help facilitate connections with the data and so on. Docker is used more as a deployment mechanism rather than to share that instance with other consumers. Does that make sense? Yes? No? So Greengrass itself, I have to confess I'm not an expert on Greengrass, but essentially what Greengrass is able to do is it interacts with SageMaker and is aware of the models that are compatible with device deployment. So if you go to Greengrass ML and you say, I want to deploy a machine learning model, it knows which models that were trained in SageMaker are compatible with device deployment, and it'll let you select that and deploy those. Over here. Go ahead.
Integration with Redshift and SageMaker. Are there any ways in which my query from SageMaker to Redshift is faster compared to a regular program?
Got it. So the question is around Redshift and SageMaker. We don't have a specific integration with Redshift. In general, the way that we view that you would want to work with SageMaker is that you'd want to use S3 as your data lake, and SageMaker will work with S3. So we have, yes. So the communication with S3 is actually optimized in a very specific way in order to make sure that we have an optimal connection between S3 and the compute instances. And that's the reason why the answer there is we don't have a specific integration with Redshift, because the way we see most customers working with SageMaker is with data that's in S3. One more question, and then I probably have to move on. Go ahead.
I do remember you mentioned something about having a SageMaker set up locally. There was something on the slide.
Yes, yes.
My only problem with working on SageMaker is to wait for a couple of minutes for it to spin up and then.
Great question. Thank you for that question. So the question was, I mentioned SageMaker set up locally because it takes time for the instance to spin up. And yes, that's absolutely one of the reasons why we created SageMaker Local Mode. You can actually use SageMaker Local Mode within the notebook instances, which lets you do a little training iteration very quickly. The way that we view it is there's two stages where you want to try and do this training. One is I'm experimenting with small amounts of data. I really need the results fast, and I want to iterate through to see what works with a 1% sample or a 10% sample, that kind of thing. And for that, you would use SageMaker Local Mode. You can use SageMaker Local Mode on your laptop if you want, or you can use SageMaker Local Mode in the notebook instances, and then train on the local notebook instance locally. It's similar APIs. You can't use all of the containers. I'm still working on that. You can use the deep learning containers because they're all open source. As we open source more and more containers, you'll have more containers that you have access to. But essentially, that's the gating factor for which ones you can use in local mode. And there's a few that are coming. We know that that's a bit of a pain point. Then at the point at which you're able to do that training locally and you're satisfied with the training and you want to actually train on a full data set, the way that we think is more appropriate to operationalize it and to work with large data is SageMaker training. And it's really built for moving from small data sets to these larger, up to petabyte scale data sets. That's really the appropriate environment. Keeping the notebook instance persistent and up and running, frankly, Intuit, and I worked on that. The initial way that data scientists were working with SageMaker was they had these persistent notebook instances, and then Intuit came to me and said, hey, our cost is really high. I'm like, yeah, because you've got data scientists that are running these M4 16XLs 24 hours a day. Of course the cost is high. Let's try and move them towards training where they're using samples of data in smaller instances on these hosted notebook instances. And when it comes time to training, they're spinning up on demand clusters of these instances, whether it's single ones, a single M4 16XL, or if they want even 10 M4 XLs, they're able to spin it up. They're able to do that training really quickly. And that's the model that we've used. So experimentation locally, and then for operational large data training that you would want to be able to use training. Make sense? Thank you all very much. I appreciate the time. And hopefully some of you will stick around for the talk on hyperparameter tuning.